On the southern edge of the sky, a distorted barred spiral in Volans bends its two unequal arms like a thrown harpoon. Observers know it by many labels: Meathook Galaxy, the twin number 2442/2443, the Volans hook, but all point to the same intermediate spiral whose bar and mismatched arms give the system its striking, hook-like silhouette at roughly 50 million light-years and on the order of 75,000 light-years across. The split designation traces back to 19th-century cataloging quirks. Early observers logged what looked like two nebulae, which later resolved into a single lopsided disk, hence the paired entries and the enduring habit of calling one arm NGC 2442, and the other NGC 2443. In this Volans oddity, the sharper, brighter arm is lined with H2 regions and threaded by a heavy dust lane, while the opposite arm kinks and fades, signatures of a recent gravitational run-in. Kinematic maps reveal non-circular motions and a briskly rotating nucleus, the dynamical fingerprints of tides that have shoved gas into shocks along the dominant arm and redistributed star formation without destroying the disk. AR-14 evidence for that encounter lingers beyond the starlight. A starless cloud of neutral hydrogen, HIPAS J0731-69, hangs nearby like a shed plume, likely torn from the galaxy during the flyby of a moderately massive companion. The hook's brightest knots are newborn clusters blazing blue against ochre dust, but its history is also written in stellar endings. A low-luminosity Type II event in 1999, SN 1999-GA, went off along one of the compact inner arms and was later revisited to study the aftermath. It marked a core collapse death somewhere in the galaxy's patchwork of recent star formation. In March 2015 another flash appeared, this time a normal Type Ia, SN 2015F, from a white dwarf pushed over the thermonuclear brink in a binary. Unusually early monitoring caught its rise and helped pin down the timing of first light, turning this lopsided spiral into a laboratory for supernova physics. Despite the drama, crooked arms, streaming gas, rippled velocities, the Volans hook remains a disk galaxy that still roughly follows the Tully-Fisher relation, a reminder that tidal harassment can bruise a spiral without breaking it. Dynamical models suggest relaxation on 100 million year timescales and the prospect of another passage, perhaps an eventual merger, in the longer future, an evolution written in tides rather than in tranquility. All of this has been traced since John Herschel first swept it up from Cape Town in 1834, when the southern skies were being charted with new care. Today's images, Hubble's close-ups of the compact arm and core, wide-field views showing the extended hook, radio maps revealing the ghostly HI plume, let the Meathook, the harpoon, the Volans spiral were its many names honestly, a single system, asymmetry incarnate, caught mid-gesture by gravity and still telling its story in light, dust, and motion. The Meathook Galaxy is a study in asymmetry that still obeys the quiet mathematics of disks. Along the brighter, tightened arm, dust lanes sit just upstream of luminous H2 knots, an offset that betrays shock fronts where gas first compresses, then lights up as clusters ignite a few million years later. Farther out, the beads on a string rhythm appears, clumps spaced by the tug-of-war between self-gravity, shear, and feedback, a natural meter for star-forming spirals. Across the bar, gas experiences negative torques and drifts inward until resonances pile it up into a compact oval. There, cloud collisions become frequent and the interstellar medium jumps phases, molecular where the pressure is high, atomic where feedback has raked it thin. The hooked spiral looks chaotic in photographs, but the flows are legible to anyone who reads bars and resonances, dust for the shocks, H-alpha for the newborns, mid-infrared for the warmed grains, radio for the cold reservoirs that keep tomorrow's stars in escrow. The Harpoon Galaxy carries scars of a past encounter that never quite broke its disk. One side shows compression and curvature, the other, stretch and dilution. Tidal forces did not randomize the orbits so much as redistribute them. Kinematic fields map this history cleanly, non-circular streaming along the leading edges, a twist in the velocity major axis, and subtle offsets between stellar and gaseous isophotes. None of it erases disk memory. The rotation curve still climbs and then plateaus against a dark matter halo, and the system's integrated luminosity and line width remain close to what the Tully-Fisher relation would predict for a spiral of this mass. The Volans hook is a reminder that galaxies can be both perturbed and predictable. In ultraviolet, the lopsided bar spiral glitters blue where massive clusters have just assembled. In optical, dust rakes the lanes like claw marks. In the mid-IR, warm polycyclic features trace the photodissociation skins of giant clouds. In the far IR and submillimeter, cold dust writes the longer story of fuel. Radio maps extend the narrative beyond starlight. Neutral hydrogen drapes well past the optical disk and spills into a detached plume, the kind of starpore debris tides love to leave behind. Molecular tracers concentrate along the bar and the inner arm, where orbit families intersect and crowd. There, turbulence climbs, cloud lifetimes shorten, and the initial mass function gets a steady supply line. The hooked disk is also a time machine for stellar evolution. Massive stars born in the compressed arm live fast and die as core collapse supernovae within the very neighborhoods that knitted them. Their blast waves punch cavities and seed magnetic order, carving superbubbles that vent along the easiest gradients. Elsewhere, older populations orbit quietly, and when a white dwarf in a tight binary tips into runaway thermonuclear burning, the flash arrives from a calmer, more metal-rich suburb. Two different endings, gravitational collapse and carbon detonation, have already lit this system, turning the Meathook Galaxy into both a forge and a yardstick. Look closely at the magnetic geometry of the southern hook and you find order inside the apparent disorder. Polarized emission tends to align with dust lanes where shocks stretch and straighten field lines, while tangled, depolarized patches coincide with stellar nurseries that have been stirred by winds and supernovae. That structure matters. Magnetic tension helps steer cosmic rays, couples gas to larger scale flows, and can even delay or promote collapse depending on how strongly it threads a cloud. In the Harpoon Galaxy, gravity sets the stage, but magnetism and feedback write the choreography of the small scale. Star formation efficiency changes from place to place across the Volan spiral. Where the arm is compressed, the gas depletion time shortens. In the sheared outer hook, clouds struggle to stay bound long enough to form clusters. Age gradients creep along the arc, the youngest knots near dust shocks, slightly older associations downstream, and redder field stars further yet, a conveyor belt driven by the pattern speed. Even the clusters themselves tell the tale, compact, bright, ionizing groups shoulder to shoulder with looser, fading associations whose O-stars have already burned out, leaving behind B-stars and the first compact remnants. Beneath the spectacle of blue knots and ochre dust lies a quieter ledger of metals and angular momentum. The asymmetric barred spiral likely holds a shallow metallicity gradient bruised by mixing. Tides are good at moving both stars and gas, and inflows along the bar can raise central abundances while outer loops dilute. The disk-specific angular momentum, meanwhile, still betrays its disk ancestry. Most stars orbit in the same sense, even if their epicycles have been widened by the past encounter. Lopsidedness, in this sense, is not an identity but a phase, one act in a longer play of secular evolution and occasional flybys. Seen edge-to-edge in deep exposures, the Meathook's outskirts feather into faint streams and plumes that barely register above the background. Those low-surface brightness structures are tidal ink, loops that trace the relative mass and orbit of the perturber, and the time since pericenter. Modelers can dial in bar strength, halo shape, and encounter geometry until synthetic hooks match the real one, then read off a likely timeline, an approach that turns a pretty asymmetry into a dynamical chronometer. The southern hook is not merely photogenic, it is instructive. Because its disk survives and its bar is strong, it bridges the regimes of violent and gentle evolution. Bar torques, resonance rings, shock fronts, shear, feedback, magnetic ordering, tidal stirring, all can be studied within a single target whose nickname is as memorable as its physics. Call it the Meathook, the Harpoon, the Volan's hook, the hooked spiral, the lopsided bar disk, each alias points to another facet of the same system, a galaxy caught mid-conversation with its environment, speaking in the grammar of rotation and resonance, punctuated by starbursts and supernovae, and legible from radio to X-rays to anyone willing to read across the spectrum. Along the crooked bar of the Volan's hook, orbit families crisscross like braided streams, and where those paths crowd, clouds collide and stick, raising the local pressure until molecules survive and collapse in earnest. The brightest clumps along the sharpened arm are the visible punctuation of that process, short-lived sentences written by O-stars whose radiation sculpts pillars and scalloped rims that face into the oncoming flow. Downstream, the grammar changes, ionized bubbles merge, stellar winds punch chimneys, and dust lanes that once looked like knife cuts thaw into filamentary lace as feedback and shear unravel the knots that birthed them. The hooked spiral looks lopsided to the eye, but its internal clock runs everywhere, advancing clusters from embedded infancy to gas-cleared adolescence in a few tens of millions of years, then dispersing them into the field as the pattern sweeps on. Tides did not just bend the arms of this harpoon galaxy, they also stirred the pantry. Gas that once orbited sedately in the outskirts now meanders inward along the bar in elongated loops, bleeding angular momentum into the stellar backbone and pooling near resonances where orbits stall. There the nucleus becomes a refinery, funneling, shocking, and heating the inflow until it fragments into star-forming rings and miniature spirals that dust renders as coffee-dark swirls. The engine hums without needing a quasar, a modest bar torque can keep it fed, and the lopsided outer arm ensures the queue never quite runs dry. From the halo's point of view, the whole exercise is bookkeeping. The dark envelope keeps the rotation flat and the disk stable enough to survive the scuffle, while the visible matter shuffles inward a little, outward a little, and writes new light where gravity allows. Look at the southern hook in polarized radio light and you'd expect to see the field lines combed along dust lanes, ordered where shock stretched them taut, scrambled where clusters froth the gas. That magnetic scaffolding does more than decorate the picture, it guides cosmic rays and regulates how quickly clouds shed their support to collapse. In places where the hook is compressed, the field aligns and star formation proceeds briskly with short depletion times, where shear winds, turbulence and magnetism tie enough knots to slow the conversion of gas into stars. The result is a patchwork efficiency map stitched to the dynamics, a bright, efficient inner segment, a kink where tides have twisted the spiral, and a paler outer sweep where clouds struggle to stay bound. Even the debris beyond the starlight carries the system's memory. Neutral hydrogen hangs past the optical edge and spills into detached clumps, a ghostly ledger that tides keep more faithfully than stars. Those cold streams trace the past encounter like chalk marks on a floor, arcs that point to the perturber's path, gradients that reveal which side was compressed and which was stretched, spur features that only appear when the geometry was just so, nearly prograde, not quite head-on. Modelers replay the scene with bars of varying strength and halos of different shapes until a synthetic meathook mirrors the real one, then read off a plausible timeline measured not in years but in pattern rotations and pericenter passages. On smaller scales, the Volan's bar spiral doubles as a laboratory for cluster demographics. Along the bright arm, beads on a string, clumps repeat with a cadence set by the competition between gravity and shear. Their colors drift subtly along the flow, from blistering blue and H-alpha bright upstream to slightly older, dust-softened associations downstream. The clusters do not age in isolation, winds knit them into shells, supernovae lace them with heavy elements, and leakage of ionizing photons etches translucent skins on adjacent clouds. Over time, the arm becomes a conveyor belt whose cargo is not gas but stellar populations, feeding the disk with field stars that remember the hook only in their kinematics. For observers, this distorted barred spiral rewards every wavelength you throw at it. In ultraviolet it is all spark and spray, young populations marking the freshest compression zones. In optical, ochre dust cleaves the bar and arms into dramatic relief. In mid-infrared, PAH bands and warm grains paint the photodissociation fronts. In far-infrared and submillimeter, cold dust maps the hidden reservoirs. In the 21 centimeter line, extended hydrogen reveals the tidal handwriting no broadband image can show. Stitch those views together and the harpoon stops being an odd shape and becomes a story you can follow, a disc nudged by a neighbor, a bar doing secular work, gas obeying torques and shocks, stars lighting the aftermath, and gravity setting the meter that keeps the whole sentence grammatical. The hooked spiral is therefore less an anomaly than a chapter in the ordinary life of discs, one where an external nudge amplifies the internal bars and spiral's engine instead of erasing it. Call it the meat hook, the harpoon, the Volan's hook, the lopsided disc, the southern hook, the distorted bar spiral, whichever alias you choose, the physics underneath is the same steady duet of order and disturbance. Rotation supplies the scaffold, tides add a twist, magnetic fields and feedback refine the details, and out of that choreography comes a galaxy that looks wild at a glance but reveals, under patient study, how resilient a spinning sheet of stars and gas can be. On the scale of orbits, the hooked spiral carries an obvious m=1 lopsidedness, a global slant that rides on top of the familiar two-armed pattern. That one-armed asymmetry shifts the center of mass a little off the photometric core and skews the phase of density waves, so shocks and star formation don't appear symmetrically on opposite sides. Near corotation, you can watch the gas make a choice. Some parcels slip outward along feathered spurs and fade into the pale outskirts, others dive inward along the bar where orbit families crowd and the shear briefly slackens. The end result is a disk that keeps time to the same rotation curve as any normal spiral, while its accents, compressions, dust lanes, UV sparks, fall out of sync in a way that gives the Volan's hook its unmistakable silhouette. The Harpoon Galaxy's inner few kiloparsecs behave like a secular engine with variable intake. Bar torques bleed angular momentum from cold gas, guiding it into lanes that hug the leading edges and ram it through standing shocks. Downstream, the material cools into molecular clouds and lights up in clusters. Where an inner Lindblad resonance lurks, inflow stalls into a pseudo-ring, a coffee-dark loop whose embedded spirals feed the nucleus with just enough fuel to sustain a modest starburst and a restless interstellar medium without tipping the system into quasar theatrics. The engine's efficiency isn't constant. Whenever tides wrinkle the outer pattern, the intake surges, and the hooked spiral breathes a little harder. In the Meathook's brighter arm, the star-forming beads are spaced by a balance between self-gravity, shear, and feedback pressure, so their cadence doubles as a seismograph of local dynamics. Upstream rims glow in H-alpha where gas first shocks, a few hundred parsecs downstream, dust cocoons break into scalloped shells, and further along, the UV light softens as O-stars age out and B-stars take over. The sequence repeats like measures in a song written by the pattern speed. Across the fainter arm, shear wins more often, clouds are stretched, pillars are shorter-lived, and clusters emerge looser and less massive, a demographic echo of how different the two sides of the Volan's harpoon really are. Magnetism threads the picture with quiet authority. Polarized radio emission tends to line up with dust features on the concave side of the strong arm, proof that shocks have combed the field into order, while depolarized patches coincide with frothy H2 complexes where turbulence tangles lines faster than they can align. Those fields help set the effective pressure in clouds, steer cosmic rays into chimneys that vent superbubbles, and influence how quickly a compressed ridge actually collapses. In the southern hook, gravity writes the score, but magnetism conducts the small-scale orchestra. Beyond the bright disk, the Meathook Galaxy carries its past in gas rather than in stars. Neutral hydrogen extends well outside the optical body and spills into detached clumps that barely form any luminescent knots, a sign that the tides that sculpted the hook were efficient at peeling gas while leaving the stellar disk intact. The kinematics in those outskirts don't perfectly trace circular motion. Gradients tilt and twist in ways that sketch the geometry of the old encounter, likely a not quite head-on, nearly prograde pass. Modelers replay such flybys with bars of different strengths and halos of varying flattening until a synthetic hook reproduces the observed plume and arm curvature, then read off a timescale measured in pattern rotations rather than calendar years. Chemistry and mixing tell a subtler version of the same story. Radial inflow along the bar tends to enrich the center, while tidal stirring and outer plumes dilute the periphery. The net effect is a metallicity gradient shallower than a quiet spirals, stippled by local highs where feedback has recycled metals into the next generation of clouds. Dust follows suit. Warm mid-infrared bands mark photodissociation skins around young clusters. Colder far-infrared emission maps reservoirs that won't light up until the next compression sweep. Energy balance across wavelengths, UV, H-alpha, mid-IR, far-IR, lets you count the hidden stars the dust is hiding and shows that the Volan's hook converts gas into starlight fastest where the bar meets the dominant arm. The distorted barred spiral in Volan's doubles as a training ground for stellar death as much as for stellar birth. Core collapse events are expected along the tight, shocked segments where massive stars live fast, while thermonuclear supernovae appear from older neighborhoods with calmer kinematics, giving the same galaxy two very different clocks to time. Their remnants punch cavities, seed magnetic order, and lace nearby clouds with heavy elements, changing the opacity and cooling curves for the next round of collapse. In this way the hooked disk writes successive drafts of itself, each supernova both an ending and a set of edits to the interstellar script. Even the dark sector leaves fingerprints on the hooked spiral's resilience. A massive, relatively round halo keeps the rotation curve flat and stabilizes the disk against complete disruption, so the lopsidedness remains a bruise, not a break. The global specific angular momentum of the stars still matches that of a disk that spun up in a quiet cosmic web, even if the epicycles are a bit wider now. That combination, robust rotation supported by an unseen scaffold, visible matter temporarily out of phase because of tides, is why the Volan's hook can look so wild and yet fall back into the same scaling relations that ordinary spirals obey. Call it the meat hook, the harpoon, the Volan's hook, the hooked bar disk, the southern hook. Under every alias it remains a living demonstration of how galaxies evolve, by steady rotation punctuated by nudges, by bars doing secular work while encounters add drama, by magnetism and feedback sculpting the small scale while a dark halo keeps the stage from collapsing. The next deep exposure or longer radio integration won't change that melody, it will simply reveal more notes, fainter plumes, subtler age gradients, quieter shells, filling in the score of a disk that has been bent, not broken, and is still busy turning cold gas into new light. Walk the outer curve of the fishhook and the surface brightness falls to whispers, but the physics gets loud. Out there, the tumor balance between self-gravity and shear wobbles right on the edge, a little extra compression from the passing pattern tips gas into collapse, a little extra epicyclic kick stretches clouds into ribbons before stars can gather. The result is a lacework of filaments and faint knots that marks the transition from a star-forming disk to a realm governed by stability criteria rather than by fuel alone. In the same territory the pattern speed leaves its fingerprints, feathers peel from the main arm at regular phase intervals, a fossil record of where the density wave once nudged the medium hardest. Back toward the bar of the Volan's hook, orbit families change character and so does the chemistry. Inflowing gas meets shocks, the molecular fraction jumps, and cooling times plummet, turbulence rises just enough to fragment without completely shredding the nascent cores. Feedback arrives on schedule, winds, radiation pressure, then the first supernovae, raising the effective pressure and briefly throttling the efficiency until the next sweep of the pattern resets the stage. The cycle is secular, torques gather material, shocks ignite clusters, feedback scours, and the bar keeps time. Magnetic fields in the Harpoon Galaxy act like an invisible truss. Where dust lanes are straightest, polarization would reveal long, ordered runs that help channel charged particles and stiffen cloud envelopes. Where H2 complexes froth, depolarization betrays tangled lines and fast reconnection. That scaffolding decides whether a compressed ridge fails gracefully into filaments or catastrophically into a beadwork of clusters, and it helps carve chimneys through which hot gas and cosmic rays vent, linking the disk to a more tenuous halo you only see in X-rays and radio. The hooked spiral is also a classroom for angular momentum bookkeeping. Gas sliding along the leading edges of the bar trades spin for binding energy, stars born from that gas inherit cooler, more elongated orbits, while older populations keep the warmer kinematics of an earlier epoch. Over gigayears, that subtle sorting builds the inner morphology we see: oval flows, mini-rings, nuclear spirals, without ever needing a blowout or a quasar to rearrange the furniture. It is the quiet triumph of secular evolution playing a duet with an old tidal nudge. Chemical abundance patterns in the Meathook are expected to be modeled rather than monotonic, the signature of inflow, mixing, and feedback happening on overlapping timescales. Pockets near the bar ends show higher metallicity where gas has been cycled more often, outer swaths run lower thanks to dilution by tidally stirred reservoirs. Dust follows the money. Mid-infrared bands light up the photodissociation skins of cloud complexes along the sharp arm, while far-infrared and sub-millimeter emissions sketch colder stockpiles in the kinked, sheared sweep on the opposite side. Star clusters along the bright arc age like tree rings stretched into a spiral. Upstream, blistering blue groups still wrapped in patchy dust. A little downstream, shells and superbubbles with O-stars already thinning out. Farther yet, associations dominated by B-stars and redder field light filling in the gaps. Measure their colors and sizes and you recover the cadence of the underlying wave, a natural clock that dates not just individual knots but the speed at which the harpoon's pattern writes across the disk. Even the parts that look empty in broadband images aren't idle. Low surface brightness HI around the lopsided bar disk preserves the geometry of the long-gone encounter better than the stars do. Slight twists in outer velocity contours reveal where the past perturber tugged hardest. Simulations that match those kinematic quirks point to a not quite head-on, nearly prograde brush, strong enough to bend an arm, not strong enough to unmake a disk, exactly the kind of cosmic bump that turns a quiet spiral into the memorable silhouette we now call the Volans hook. In the long forecast, nothing about the fishhook's fate is catastrophic. The dark halo keeps the rotation curve flat and the sheet resilient. The bar will continue to wick gas inward and light compact circumnuclear spirals. The strong arm will keep stamping out beadwork where shocks run cleanest. The faint arm will keep trading brilliance for breadth as sheer stretches what gravity tries to gather. If a former companion loops back for another pass, the choreography will sharpen. If not, secular processes will slowly round off the bruise into a more symmetric disk, leaving only the faintest plumes in the outskirts as a memory. Call this system the Meathook, the Southern Hook, the Harpoon, the Hooked Bar Spiral. Every alias fits because each name's a different register of the same instrument. Rotation holds pitch, tides add harmony, bars set rhythm, magnetism tunes the small-scale timbre, and feedback improvises over it all. What looks like a cosmic accident from afar is, up close, a resilient machine turning cold gas into new light with clockwork regularity, even as a single, dramatic arm keeps reminding us of the moment a neighbor's gravity nudged the melody into its unforgettable shape. Astronomers read the hooked spiral like a score by measuring how patterns move through it. One way is the Tremaine-Weinberg trick. Treat bright tracers as beads on a conveyor belt and infer the bar's pattern speed from how light and velocity line up along slits. In a system like the Volans hook, corotation tends to fall near the kink where the dominant arm changes pitch. Inside that radius gas drifts inward along the leading edge shocks of the bar, outside it peels outward into feathers. Translate those kinematic cues into timescales and you get a rhythm of a few pattern rotations per few 100 million years, long enough for tides to bruise the disk yet short enough that the bar keeps the engine running between encounters. Star clusters along the sharpened arc obey familiar demographics. Count them by mass and you recover a near power law distribution with a slope close to -2, meaning there are many more modest groups than giants, but the giants that do appear grab your eye in most of the UV. Their lifetime's trace environment. Near the bar ends, stronger tides and higher pressures prune fragile associations early, infant mortality, while in the quieter outer sweep, looser groups drift apart more gently. The result is a color and size gradient that doubles as a travel diary for each bead on the string, blistering blue and compact upstream, shell-rimmed and slightly redder downstream, then dissolving into the field. The interstellar medium in the Meathook behaves like a three-phase ledger. Dense molecular gas piles up along dust lanes where shocks and bar torques compress it. That reservoir glows in CO and feeds the most efficient cluster factories. Surrounding it sit CO faint, dark H2 traced better by C2, and far IR dust emission, common where UV fields nibble at cloud skins. Farther out, atomic hydrogen dominates, kinematically colder than the stars but easily stirred by tides. Plot gas surface density against star formation rate and the system lands on the Kennicutt-Schmidt relation on average, yet patch by patch the slope bends with dynamics, steeper where inflow concentrates fuel, flatter where shear stretches clouds before they can collapse. Dust grains tell the small-scale weather. Along the knife-edge arm, PAH bands weaken right behind the hottest clusters, tiny molecules shattered or ionized by hard radiation, while slightly downstream warm, very small grains re-radiate starlight in the mid-IR and cold silicates carry the far-IR load. In shocks, big grains can fracture into smaller ones, in quieter pockets they coagulate back into fluffier aggregates. Those microphysics modulate how quickly gas cools and how readily clouds shield themselves, feeding back into where the next round of stars will appear. The harpoon's photogenic clumps are, in part, dust chemistry made visible. Cosmic rays and magnetic fields lace the fishhook with invisible structure. Where the field is combed along dust lanes, synchrotron emission brightens and the spectral index flattens, freshly accelerated electrons and ordered lines. In frothy H2 complexes, turbulence tangles the field, depolarizing radio light and steepening the spectrum as electrons age. Superbubbles vent along the path of least magnetic resistance, opening chimneys that couple the disk to a faint, warm halo. Even without a quasar's fury, the hooked spiral leaks energy upward, it just does so through many small valves rather than a single blowtorch. Dynamically, the lopsidedness rides on swing amplification and tidal prompting. A near prograde flyby seeds an M=1 mode, the bar then shears, compresses, and rephases that disturbance into the single dominant arm we see. Over several rotations, the asymmetry decays unless another nudge arrives, but its aftereffects, redistributed angular momentum, mixed metals, migrated stars, linger longer. That's why the Volan's hook can look wild in starlight yet sit comfortably on disk scaling relations. The dark halo keeps the scaffold stiff while the luminous matter slips temporarily out of phase. Chemically, the system carries the signature of both inflow and stirring. Central gas tends to be more metal-rich where the bar has cycled it repeatedly, the outer kink and detached HI clumps red lower because of dilution by tidally stirred reservoirs. Local spikes appear around superbubbles where fresh heavy elements seed the next clouds. Stitching those patches into a gradient recovers a slope shallower than in a perfectly calm spiral, a quiet fingerprint of mixing by bars and tides rather than by mergers. Compared to classic interaction pairs like M51, the southern hook sits in a gentler regime, no grand two-arm symmetry, no overwhelming companion torque, just a stubborn bar and a memory of a brush by. That makes it ideal for testing how internal, secular processes and external nudges add rather than substitute. You can watch bar inflow build a pseudoring without erasing the disk, see bead spacing respond to shear without global collapse, and measure how HI plumes remember the flyby after starlight has forgotten. The next instruments sharpen different chapters of the same story. Millimeter arrays resolve cloud life cycles along the strong arm, separating prestellar cores from feedback-shocked shells. Sensitive low-frequency radio maps trace aged cosmic rays bending around the outer hook. High-resolution infrared imaging counts embedded clusters where optical dust lanes go opaque, tying age sequences to exact shock offsets. Each wavelength fills another line in the ledger of a galaxy that, whatever name you give it, the Meathook, the Volan's hook, the harpoon, the hooked bar disk, demonstrates how a rotating sheet of stars and gas can take a cosmic nudge, bend into an unforgettable shape, and keep calmly manufacturing light. Out in the pale outskirts of the southern hook, the disk enters a regime where stability is negotiated, not guaranteed. The tumor Q parameter hovers near unity. Slight boosts in surface density from the passing pattern or from epicyclic crowding can tip filaments into collapse, while a nudge of shear unspools the same filaments back into the diffuse medium. That push-pull writes a fractal shoreline of star formation, tiny OB associations lighting one ridge while the next ridge dissolves into HI spray, a living map of how rotation and turbulence arbitrate what becomes a cluster and what returns to drift. Closer in, the bar-end region is a natural laboratory for orbit crowding and gas shocks. There, families of X1-type orbits funnel material along the leading edges, and as the stream bends into the arm, the flow rams a standing shock that piles up dust just upstream of the brightest H2 knots. The offset between the dust lane and H-alpha glow doubles as a clock, the time it takes compressed gas to cool, molecule-rich pockets to form, and massive stars to switch on. Measure that offset along the hooked arc and you can back out both the pattern speed and the local efficiency with which the inflow turns fuel into newborn clusters. The lopsided bar disk also records mixing in its chemistry. Inflow raises central abundances by recycling previously enriched gas, while tidal stirring and the long outer sweep dilute metallicity on the opposite flank. Resolved spectra should show shallow gradients peppered with local plateaus around superbubbles where fresh heavy elements are re-injected. Dust responds in kind. PAH features weaken right behind the most intense UV sources, mid-infrared continua brighten in their wake, and the far-infrared quietly totals the colder inventory that will feed the next shock-triggered burst. Clumps along the sharpened arm follow the familiar, beads on a string, cadence set by the competition between gravity and shear. Their masses and radii sketch a near power law census with many modest associations and a few headliners that anchor the UV image. Age gradients drift along the flow, ionization fronts hard and blue at the shock, shell-rimmed clusters a few hundred parsecs downstream, then looser groups whose O-stars have already burned out. By the time those populations fade into the field, kinematics, not color, holds their memory of the Meathook's bright arc magnetism underwrites much of this choreography. Polarized synchrotron ridges tend to align with the concave side of the strong arm where shocks have combed the field straight, while depolarized, tangled zones track frothy H2 complexes. Ordered fields stiffen cloud envelopes and guide cosmic rays into chimneys, helping superbubbles find vertical escape routes without shredding the arm. The net effect is to accelerate feedback where compression is clean and to slow collapse where shear and tangled lines dominate, a patchwork map of star formation efficiency stitched to the dynamics. Kinematically, the Volan's hook is a textbook in mild disturbance. Harmonic decomposition of its velocity field would show non-circular streaming along the bar, a twist in the major axis across the arm kink, and gentle asymmetries in the outer rotation that betray the old tidal tug. Yet the rotation curve still rises and flattens like a healthy disk pinned by a massive halo. Scaling relations that tie luminosity to line width remain intact because the scaffold, dark matter plus ordered spin, never gave way, even while the luminous material fell temporarily out of phase. On cloud scales, a full life cycle plays out along a single sweep of the harpoon. Prestellar condensations gather in the dust lane upstream, embedded clusters ignite and begin pushing back, winds and radiation pressure carve shells that merge into superbubbles. The next inflow encounters a pre-stirred medium whose turbulence spectrum has already shifted. Millimeter interferometers pick apart this sequence by isolating dense gas tracers from more diffuse CO emission, while far UV through near-IR photometry ties each knot's age and extinction to its place on the conveyor belt. The faint gas beyond the starlight keeps the encounter's ledger more faithfully than the stars do. Extended HI drapes past the optical rim and spills into off-disk clumps that form few if any clusters, implying that tides peeled gas more efficiently than they displaced the old stellar population. Subtle twists in the outer velocity contours point to a nearly prograde, slightly off-center brush, strong enough to bend one arm into a harpoon, not strong enough to unmake the disk. Numerical flybys that match the plume geometry naturally reproduce the arm's unequal pitch angles and the bar's current torque budget. Even without a blazing nucleus, the hooked spiral vents energy upward. Hot superbubble interiors leak through low-density corridors set by field geometry. Faint, warm ionized gas glows in diffuse halos. Aged cosmic ray electrons sketch soft radio cocoons that mirror the arm's curvature at larger radius. This gentle, galactic breathing couples the disk to its surroundings and seeds the circumgalactic medium with metals and magnetic flux, a slow-motion exchange that proceeds through many small valves rather than any single outburst. Call it the Meathook, the Harpoon Galaxy, the Volans Hook, the Southern Hook. Under every nickname it remains a resilient machine whose apparent drama is just gravity's patience made visible. A bar bleeds angular momentum, a past nudge sets an m=1 slant, magnetism and feedback sculpt the small scale, and a dark halo keeps the rhythm. From dust lane clocks to HI plumes, from polarized ridges to age-graded beads, the system offers one of the cleanest chances in the nearby universe to watch a spinning sheet of stars and gas absorb a cosmic shove, bend into an unforgettable silhouette, and keep calmly manufacturing light. Out beyond the bright hook, the debris that tides once peeled away doesn't simply disperse, it drifts, slows, and sometimes rains back in, a quiet galactic monsoon that seeds the next cycle of star formation. Reaccreted streams arrive with off-kilter angular momentum, thickening the outer disk and nudging the lopsided pattern to persist longer than a single flyby would suggest. In that slow exchange between disk and halo, the Harpoon keeps its asymmetry alive not by force, but by habit, fuel delivered slightly out of tune with the underlying rotation. Photometrically, the hooked spiral wears its dust like a mask that changes the scene depending on wavelength. Blue light exaggerates the bruise, strong extinction across the knife-edge arm and a paler, sheared sweep opposite, while the near-infrared reveals the bar's older backbone almost symmetrically, reminding you that the stellar mass map is calmer than the star formation map. Correct for that dust and the underlying disk look surprisingly regular, leave it in place and the drama of shocks, cocoons, and shells tells the day-to-day story of gas learning the bar's grammar. Stellar populations in the Southern Hook mix like layers in sedimentary rock laid down by a tide that arrives every rotation. Young clusters, a few million years old, line the concave edge of the dominant arm, intermediate age associations trail behind like foam, redder giants collect toward the bar and inner oval where orbit families overlap. The metallicity pattern is mottled but shallow in slope, a fingerprint of inflow enriching the center while tidal stirring and outer plumes keep the outskirts from running too far ahead or behind. Dynamically, the fishhook's outline can be understood in terms of the manifolds that emanate from the bar's ends, cosmic exit ramps at the Lagrange points where orbits peel off into trailing lanes. On one side those streams stay cohesive and bright, corralling gas into a single dominant arm, on the other, shear and a slightly different phase scatter them into feathers. The result is a system that looks like a rule breaker but is actually following the bar's geometry with textbook obedience. Compared with classic showpieces like the Whirlpool, this lopsided bar disk sits in a subtler regime, where a modest external nudge amplifies internal structure rather than overwhelming it. That's why the Volans hook is so valuable theoretically. It lets you separate what bars do on their own, bleeding angular momentum, building pseudorings, feeding circumnuclear spirals, from what a neighbor adds, an m=1 slant, a kinked outer arm, stray HI plumes that remember the encounter after starlight forgets. Supernova archaeology along the bright arc adds time-stamped footnotes to the narrative. Core collapse remnants expand into pre-stirred cavities, lighting rims where winds and shocks have already lowered the density. Thermonuclear events pop up from older, quieter neighborhoods, serving as standard candles that, almost incidentally, measure a distance to the hook while its own physics plays out. Each blast slightly re-edits the interstellar medium, a handful of new metals here, a reshaped magnetic corridor there, small changes that add up when counted across 100 million years. The central engine doesn't need a quasar to matter. A bar-fed, ring-like inflow can maintain a compact starburst and a restless, clumpy interstellar medium whose turbulence keeps cloud lifetimes short and collapse efficient right where orbit families crowd. If the bar ever slows, as it trades angular momentum with the dark halo, the resonances migrate outward, and with them the ring. The refinery moves its address but keeps refining just the same. On vertical scales, feedback lifts warm gas and cosmic rays into a faint halo shaped by field geometry rather than brute force. Superbubbles punch chimneys where magnetic tension yields, and the outflow drifts rather than roars, seeding the circumgalactic medium with metals and flux. Later, some of that material cools and falls back, closing a fountain cycle that keeps the harpoon's outskirts chemically alive without needing a merger to stir the pot. Observers can read different chapters by choosing their light. Galaxy-like ultraviolet frames announce where compression has just paid off. H-alpha sketches the ionization fronts with surgical clarity. Mid-infrared bands reveal photodissociation skins where tiny grains and PAHs glow. Far-infrared and sub-millimeter maps weigh the cold reservoirs that tomorrow's beads will draw from. 21-centimeter radio contours pull back the curtain on the gas the stars haven't yet claimed. Put those layers together and the meathook ceases to be a curiosity and becomes a ledger, each wavelength a column in the accounting of torque, shock, collapse, and feedback. Even for backyard telescopes in southern latitudes, the crooked bar is a rewarding quarry. Under dark skies, the brighter arm shows a hint of curvature, and long integrations begin to suggest the unequal twins that earned the system its nicknames. Narrowband filters tease out the scattered knots, careful processing pulls the faint outer sweep into view. Amateur data, stacked patiently, end up echoing the same asymmetry that professionals quantify with interferometers and integral field spectrographs, a democratic galaxy, photogenic at any aperture. In the long view, the southern hook's fate hinges on patience. Absent a disruptive merger, the bar will continue to wick gas inward, the strong arm will keep stamping out cluster beadwork where shocks run cleanest, the sheared side will remain the place where clouds almost, but not quite, hang together, the HI plumes will thin as reaccretion and ionization erode their contrast. Given time, the bruise may soften, but the disk will remember, slightly wider epicycles, a shallower gradient, a bar that has migrated and perhaps buckled into a low-contrast boxy bulge, all quiet testimonies to a nudge absorbed rather than a structure destroyed. Call it the meat hook, the harpoon, the Volan's hook, the southern hook, the hooked spiral, the aliases are many because the facets are many. Under every name you find the same resilient machine, a rotating sheet kept honest by a dark scaffold, tuned by a bar, tilted by an old encounter, and refined by magnetism and feedback into a patchwork of shocks, clusters, shells, and plumes. What first looks like a cosmic accident resolves into a system obeying clear rules, only offset, delayed, and braided, so that gravity's grammar can write an unforgettable sentence in the shape of a single, dramatic arm. Seen in integral field spectra, the hooked bar spiral resolves into a quilt of excitation regimes that trace its internal weather. Along the knife-edge arm, line ratios stack into classic H2 signatures where young clusters flood their cocoons with photons. Just upstream, shocks betray themselves with enhanced low ionization lines as gas slams into the standing front. Deeper toward the bar, composite zones hint at mixed illumination where older populations and diluted radiation fields overlap. Stitching those diagnostics along the flow turns the meat hook into a moving laboratory. Ionization, shock strength, and density all change in step with the pattern, a choreography written by torque and shear rather than by chance. Underneath the glowing tracers, the mass skeleton is calmer. In the near-infrared, the bar's old stars form a fairly symmetric spine. The obvious asymmetry belongs mostly to dust and gas, not to the ancient stellar disk. That contrast matters. It explains how the harpoon can look wildly lopsided in blue light yet keep stable rotation and a tidy relationship between luminosity and line width. The dark halo holds the tempo, the old stars carry the bass line, and the gas solos, loudly, brilliantly, and briefly, where the conductor, the bar, cues a crescendo. Cloud life cycles along the bright arc read like a conveyor belt of cause and effect. Compression in the dust lane spawns dense clumps, within a few mere, the first O-stars ignite and begin to dig, their winds and radiation pressure clearing cavities that merge into scalloped shells. Supernovae follow, welding shells into superbubbles and seeding fresh metals into the surrounding medium. By the time the next wave of inflow arrives, turbulence has been pre-stirred, magnetic fields have been stretched, and cooling curves have shifted, conditions that either accelerate or delay the next collapse depending on how closely the new gas retraces the old paths. At the ends of the bar, orbital manifolds act as cosmic exit ramps, guiding streams into trailing lanes. On the side that becomes the dominant arm, those manifolds stay cohesive long enough to shepherd gas into a single bright strand. On the opposite side, a small phase offset and higher shear shred the streams into feathers. That geometry is enough to explain the harpoon silhouette without invoking a heavyweight intruder. A modest flyby planted the seed, but the bar's own dynamics amplify and sustain the one-armed show. If the bar trades angular momentum with the halo and slows, a secular inevitability, its resonances will drift outward. The circumnuclear pseudoring will migrate, the beat of inflow will change key, and the pattern speeds of arm and bar will rephase. None of that demands fireworks, it is evolution by ledger, a few percent off the bar's speed here, a gentle outward slide of resonances there, a gradual reshaping of where the hook stamps out its beads. The outer disk of the Volan's hook is a classroom for marginal stability. There, Tumor's Q hovers around unity and small nudges decide outcomes. An extra dollop of surface density from a feather tips a filament into collapse, a smidge more shear unravels it. That balance imprints a fractal frontier of star formation, faint knots and half-erased filaments etched into HI, so sensitive to phase that two adjacent ridges can live radically different fates despite nearly identical ingredients. Metallicity across the hooked disc tells a story of mixing rather than of monotone gradients. Inflow along the bar recycles enriched gas into the center, tidal stirring and outer plumes dilute the far side, local peaks bloom around superbubbles where fresh heavy elements have just been minted. The slope ends up shallower than in a quiet grand design spiral, but the patchwork is richer, chemical weather tied to dynamical seasons. Magnetic fields thread this narrative with quiet discipline. Polarization ridges align with dust lanes where shocks have combed the field taut, granting clouds a little extra stiffness against fragmentation. Depolarized patches coincide with frothy H2 complexes where turbulence tangles lines faster than they can realign. Cosmic rays surf those fields into vertical chimneys, venting energy into a faint halo that glows softly in radio and low surface brightness H-alpha. Even without an active nucleus, the harpoon breathes, upflows from many small valves, downflows as cooled gas rains back in, a fountain that slowly magnetizes and metals the circumgalactic medium. On longer timescales, stellar migration will soften the bruise. Transient spirals and the bar scatter stars at corotation, letting them swap angular momentum without heating the disk excessively. Over gigayears that mixing rounds off age and metallicity contrasts, leaving subtle kinematic signatures, slightly wider epicycles on the hooked side, a touch more vertical thickness where reaccreted gas settled out of plane, a boxy peanut hint if the bar eventually buckles. The memory of the encounter fades in color before it fades in motion. Observationally, the crooked spiral rewards patience and variety. Ultraviolet shows where compression just paid off, H-alpha traces ionization fronts with surgical edges, mid-infrared PAH bands reveal the photodissociation skins, far-infrared and sub-millimeter weigh the cold stockpiles, CO maps follow the dense reservoirs, 21 cm contours expose the plumes that stars haven't claimed. Add integral field kinematics to see the streaming, and polarized radio to read the field geometry, and every alias, Meathook, Harpoon, Volan's Hook, Southern Hook, resolves into facets of the same machine, a rotating sheet nudged off balance, yet stubbornly faithful to the grammar of disks. In that light, the Galaxy's drama is not an exception to the rules but a demonstration of them. A gentle tidal shove awakened an m=1 slant, a bar did the steady work of torque and transport, magnetism and feedback set the small-scale tempo, a dark halo kept the stage from collapsing. What we see as a single, unforgettable arm is gravity writing in italics, same syntax, sharper emphasis, turning cold gas into new light with clockwork regularity while carrying, in its bent outline, a legible memory of the day a neighbor drifted too close. The southern hook is a natural census-taker of extremes, hosting both the soft glow of red supergiants and the needle-bright signatures of wolf, rayet stars in pockets where the compressed arm has just minted its most massive clusters. Those brief, helium-rich phases salt the spectrum with broad bumps and high excitation lines, a chemical flare that announces how top-heavy the most intense ridges can become for a few million years. Farther down the conveyor, the same clusters fade into OB associations, then into looser groups whose brightest voices shift from ultraviolet to blue, then to the redder light of aging giants. Follow that drift and you recover a star formation history written not in a single burst but in a sequence of overlapping beats, each tied to where the bar and spiral met at just the right angle to squeeze the gas. High-energy tracers add a sharper accent to the melody. Along the bright arc, point-like X-ray sources tally high-mass binaries born in the recent surge, while nearer the bar and inner oval, older low-mass systems contribute a steadier, quieter chorus. The few ultraluminous outliers, if present, would likely sit in the densest star-forming knots where massive progenitors and close binaries are common, carving tiny cavities and pushing on the local medium with jets and winds. Even without a blazing nucleus, the harpoon can be an efficient particle accelerator on cluster scales, and radio continuum maps reflect that, flatter spectra and brighter ridges where fresh electrons and ordered fields live, steeper and softer halos where the population has aged. Dust, so responsible for the Hooke's photogenic drama, is also a diagnostic instrument. In the knife-edge arm the attenuation curve can tilt grayer where turbulence mixes grains of many sizes, muting the classical 2175A bump. Downstream, as shells merge and UV fields soften, the small aromatic carriers that power mid-infrared bands recover, lighting the photodissociation skins of cloud complexes. Grain growth and shattering play out in step with the dynamics. Shocks fracture larger particles into fresh small grains, quiet intervals let them coagulate back into fluffier aggregates that cool gas efficiently and help the next round of collapse to proceed. Vertical structure gives the lopsided disk a quiet third dimension. Reaccreted streams with slightly misaligned spin thicken the outskirts into a mild flare, while superbubbles ventilate the bright arm and leave chimneys that lift warm ionized gas a kiloparsec or two above the plane. Polarized emission often outlines those escape routes, implying that the field geometry, not brute force, sets the valves through which energy and metals leak into the halo. Over time the fountain closes its loop, some gas cools, settles back with a small lag in angular momentum, and quietly feeds the next pass of the pattern. Environment explains the system's poise. The Volans hook doesn't live in a crushing cluster where ram pressure scours disks. It keeps company with a few modest neighbors whose tides can bruise without breaking. That's the sweet spot for asymmetry that lasts, a nearly prograde brush to seed an M=1 slant, enough mass in the perturber to peel an HI plume, a strong internal bar to amplify one side into a dominant arm and to keep secular inflow humming while the outer disk rides out its wobble. The absence of wholesale disruption is why scaling relations stay honest even as the face of the galaxy looks wild. Dynamics inside the bar continue to refine the picture. As the stellar backbone trades angular momentum with the dark halo, its pattern speed drifts and resonances migrate outward, carrying the circumnuclear pseudoring with them like a rippling traffic circle. New orbit families turn on as others fade, subtly rephrasing where gas stalls and where it streams. None of this requires fireworks, the refinery keeps working, just moving its address in slow motion, and the hooked silhouette above it keeps stamping out beads where shocks run cleanest. Cloud life cycles along the strong arm resolve into measurable delays that double as rulers. The offset between the dust lane and the H-alpha bright ridge clocks the time from compression to ignition. The gap from H-alpha to peak mid-infrared emission measures how quickly young stars clear their cocoons. The softening of UV downstream dates the moment when O-stars hand the stage to longer-lived B-stars. Set those clocks against the local streaming speed and you read off the pattern speed and shear, turning a pretty image into a kinematic diagram you can hold in your head. Chemistry keeps pace with that choreography. Central gas grows incrementally more metal-rich where inflow recycles it through star-forming rings. The sheared, paler side of the outer disk trends lower thanks to dilution by tidally stirred reservoirs. Localized peaks bloom around superbubbles where fresh heavy elements have just been minted and folded back into nearby clouds. The net gradient ends up shallow but stippled, a fingerprint of mixing by bars and tides rather than by major mergers. Even the apparent emptiness carries memory. In deep 21 cm maps, diffuse hydrogen drapes beyond the optical rim and into detached clumps with little or no starlight, a ledger entry that the stars have already forgotten. Those plumes and twists in the outer velocity field point to a not quite head-on, nearly prograde pass, strong enough to bend an arm into a harpoon, not strong enough to unmake a disk. Numerical experiments that reproduce the plume geometry naturally recover the unequal pitch angles and the present torque budget of the bar, linking a single snapshot to a plausible timeline measured in pattern rotations. For observers, the crooked bar rewards a multi-wavelength approach and a little stubbornness. Ultraviolet frames mark where compression just paid. H-alpha sketches ionization fronts with razor edges. Mid-infrared bands trace the skins of clouds that hard radiation has nibbled. Far-infrared and sub-millimeter weigh the cold reservoirs the next shock will tap. CO lines map the dense fuel along the lanes. Polarized radio light reveals where fields are combed and where they're tangled. Integral field spectroscopy ties the velocity story to the light. Stack those views and the Meathook, the harpoon, the Volan's hook, choose your alias, resolves into a single argument made many ways. A rotating sheet of stars and gas can take a nudge, bend into an unforgettable outline, and still keep time to gravity's steady beat as it turns cold matter into new light. On the scale of single clouds, the hooked spiral shows how geometry becomes destiny. Where the bar meets the dominant lane at a clean angle, orbit crowding makes shocks nearly steady, so clouds enter the compressor like logs through a sawmill and leave as dense, self-gravitating knots. Where the angle is sloppier, shocks stutter, turbulence wins, and the medium stays filamentary with only scattered, smaller clusters. That sensitivity explains why two segments with similar gas mass can differ so much in ultraviolet brightness. The harpoon does not just supply fuel, it sets the terms of conversion. Pressure, shear, and magnetic tension form a three-way negotiation whose outcome you can read in the cadence of beads, in the spacing of dust scallops, and in how quickly H-alpha hands the baton to mid-infrared glow downstream. The lopsided bar disk also demonstrates radial migration in real time. At corotation, stars exchange angular momentum efficiently with the pattern and drift without being violently heated. Over hundreds of millions of years, that quiet shuffling rounds off age and metallicity contrasts that tides first exaggerated. You end up with a population map that looks surprisingly smooth in the near-infrared even while blue light keeps advertising the asymmetry. The Southern Hook's lesson is subtle but general. Morphology can be loud while the mass distribution hums along in a lower, steadier key. Cold gas physics in the Volan's hook rewards close bookkeeping. Dense gas tracers pile up along the dust ridge, but a substantial fraction of hydrogen hides in CO faint molecular skin that defeat simple calibrations. Far infrared and C2 pick up the slack by tallying photodissociation fronts that wrap each complex. Tie those to the local streaming speed and you recover a practical recipe. Where compression is clean and the field is ordered, the depletion time shortens. Where shear and tangled lines dominate, the same surface density buys less starlight. The hooked spiral is not starburst in the headline sense, yet in its best aligned segments it achieves efficiencies that rival the compact circumnuclear rings of more symmetric barred disks. The Meathook Galaxy also hints at how bars evolve under the drag of their own work. As torques ferry angular momentum outward, the stellar backbone slowly slows, resonances creep, the pseudoring migrates, and the inflow beat changes phase with the outer arm. If the pattern eventually buckles, the inner light will puff into a boxy peanut silhouette when viewed edge-on, a fossil of vertical resonances turning a flat bar into a thickened one. None of that drama is required to keep the harpoon's outline vivid. It is enough that the bar keeps time and tides keep the melody tilted. High-energy punctuation marks continue to edit the interstellar script. Along the bright arc, fresh supernova remnants expand into a medium the previous generation has already stirred, so shock fronts run faster along low-density channels and stall where compressed ridges remain. Those cavities herd cosmic rays toward vertical chimneys that polarized radio maps outline, connecting the disk to a warm halo where metals and magnetic flux accumulate by increments. Later, some of that cargo cools and returns as oblique drizzle, a fountain that thickens the outer sheet and quietly feeds the next round of compression along the hook. Even the apparent negatives, lopsidedness, unequal pitch angles, detached HI, turn out to be assets for theory. Because the perturbation was modest, the Volan's hook lands in a regime where internal dynamics dominate while the external nudge merely biases the outcome. That makes it a clean benchmark for manifold-guided spirals, for swing-amplified m=1 modes, and for secular inflow that builds circumnuclear structure without invoking a quasar. Compare this hooked spiral to Magellanic Type 1 arm systems or to classically symmetric grand designs, and you can watch how small differences in encounter geometry and bar strength decide whether a galaxy grows a single emphatic arm, two balanced ones, or only a faint lopsided glow. For observers, the playbook is straightforward and rich. Use ultraviolet to flag the freshest compressions, H-alpha to clock the offsets between shocks and ignition, mid-infrared to weigh dust heating, far-infrared and sub-millimeter to inventory the cold stockpile, CO and dense gas lines to measure the true fuel, 21 centimeters to read the tidal handwriting, integral field spectroscopy to map the streaming, polarized radio to trace the field architecture. Stack those layers and the Meathook, the harpoon, the Volan's hook, pick your alias, stops being a curious shape and becomes a legible machine, rotation for rhythm, a bar for meter, a tidal nudge for accent, magnetism and feedback for orchestration, and a dark scaffold to keep the stage firm while new stars keep taking the spotlight.